Okay, welcome back again. Now we have for 7.2, we have natural logarithm. You saw this one before. The important things here is what? The first graph of the ln. Natural logarithm means that ln f of x is equal to ln of x. The first graph. The second domain of this function and range of this function. This is the second important thing. The third, properties. The fourth, derivative. The fifth is what? Integral of the, or how we get the integral. So these are important. I'm going to repeat it for you again. So we have what? We have ln and the graph and the domain and range at the beginning. So here you are, you can see the definition and the graph here. Okay. So I'm going to give you the detail of that graph and relation with E, derivative of it. So before we are going to that one, let me start from here, give you such clue. 7.2, natural logarithm. So I have f of x is equal to what? We say ln of x. Okay, now the graph. The graph is like that. We have this line, ln is like that. So it's going to something else. Here, this point is very important. With what? With 1 and 0. That one is the function ln of x. You know, from the function, from the graph. Okay, go to the other side, please. Okay, thank you. From the graph, we can answer many things here. At the beginning, domain and range. So how domain is equal to what? Yalla. Domain is equal to what? They? You can see from here, right? From here, because we have a shadow. Am I right? Also, we have a shadow here. Also, we have a shadow here. So I can say the domain of this function, like ln of x, start from 0 to infinite. I don't know, Joe. Now, any question about the domain? Understood? Why? You can see from the shadow. We have an open here, open gap. So that's why. This is the first. The second is what? The second is range. So range is equal to what? Yalla, we see the shadow of, yes, the shadow of what? Of the y-axis. Am I right? So here's the positive infinity. You can say from 0 to positive infinity. 0 is include and minus infinity. So it's r. Am I right? It's r. So this is the very important for you to understand about that one. Also, if you have a graph, you can answer ln. For example, I say limit of x approach to infinity at what? At what do you say? For ln of x. So when x is going to infinite over x axis, look at here and answer. It's chapter 2, is included for final exam. Careful. So if x is going to infinite from positive side, so the graph is going to where? Look at it. It's going to where? I'm going to infinite from positive side. So the graph is like that. It's going to where? Positive infinite. You are right. So you can see from here, I'm going to change it by the another color. For example, let it be red. So when this one is going to be to infinite here, this graph is going to be increased. So that's why we see is equal to infinite. These very important for you. The second important thing is what? As limit x approach to 0, but from the right side. Where's right side on the picture, please? Here's the 0. That one is left side, that one is right side, that one is 0 itself. We don't have a 0. Why? Because 0 is not included. Am I right? So that's why I say it's going to be what? When limit, here's the graph. That one's a curve. when x approach to 0 from positive part or right side. So tell me about the graph. Is where? Minus infinity. You can see from here. I'm going to here, and the graph is going to be where? Here's the graph. It's going to minus. So that's why I say limit x approach to 0 from right side for this function will be minus infinity. Thank you. Any question? Easy? You got it? Good. So that's about graph, domain, and range. Limit about this function generally speaking. Understood? So use your calculator, please, if you can. Find ln of minus 2.5 and tell me is equal to what, please? If you can use it. Yalla. Okay. Ln of minus 2.5 or 0.9. Okay. What else? Doesn't exist. What else? Why? 1.6 again. Yalla. Any other number? Hello? Does not exist. Why? We say the domains from 0. Yes. So mine is not included. Am I right? That's why you get error. Sometimes you get error in your calculator. Because we say that in the front. That's why sometimes I say the student cannot use, or they do not use, or they don't know how to use the calculator, because the calculator depends on the math graphs. Am I right? For example, ln, none of them. So that's why we say the domain of the ln is what? Domain of the ln is start from 0 to infinite, then to infinite to minus infinite. So it means that I cannot include, give, minus, or even 0. Why? Because you can see here 0 is out, right? Is exclude. You cannot even give the ln of 0 to get something else. So if I say ln of 0, again I'll get what? Error or nothing else. Syntax error, math error. So how about ln of 0.001? I know I will get negative value. How about ln of 1.001? I am sure that without calculator, I will get positive value. How do you know? Because here I am. I'm in the balance point. Look at here. I'm a maximize crowd, zoom crowd. Look, I'm at the balance point. This balance is like that. If I am at 1, I have a 0. Am I right? The level of the function is 0. If I'm going to other side, I say ln of, for example, 2. Here's 2. So I will get positive value over y-axis. When I say ln of half, I'm in the negative value. Can you imagine? So I am here at the balance. At 1 is 0. Greater than 0 will be positive. Less than 0, before 0, less than, 1, till 0 will be negative value. That's why. So that's all information, or the more detail about ln. So I'm going to talk about something else. Careful, ln of e will be equal to 1. Let this one be in your mind for the next section. Next section, or maybe next week, or I don't know, next lecture, we are going to talk about this property, just like an alarm for you to remember it there. Now we have a derivative of ln. Now we have a function, the ln, and we have an image, graph, domain, range. Now it's time for what? Time for the derivative and the integral. So if your function y is equal to ln of u, be careful. When I say derivative, careful. That one also is very important, because you know, derivative and antiderivative, derivative and integral, they are completing each other. So if you are controlling that one, later you can control the integral. So Kakajan, derivative is equal to what? 1 over u prime. That's the rule. So I'll give you many examples to get the idea. Okay. So y is equal to what? For example, we say y equals a simple example. X, ln of x, I mean. So the derivative is equal to what? Y prime. I say 1 over x, derivative of x is equal to 1. That's why I will get 1. Maybe you understand or not. Look at the second example. Y equal to x squared plus 5. Sorry. The next example, ln of x squared 5x plus 2. Now give me the derivative. So I say 1 of that one first, without thinking. Just I say 1 of that one. Okay. Now derivative of here. I know it's equal to 2x plus 5. That's all. Easy, right? So careful is very important, because during the antiderivative, I'm going to use this strategy again. So during that one, you will be stuck because you don't know about the derivative. You forget. So you cannot reback it. You cannot, what do you say, bring all this information that you got. So careful, please. Try to deal with that one now, or memorize that one. This is the rule that we talk about that one. Here's the example 1, 2, 3. We got so many examples. Now let me complicate your example, because I know you like math a lot. That's why I'm going to give you more example, okay? To be complicated, because during actually the exam, I will not give you 1 over x. I'm give you such example like that. Y is equal to ln of sine x plus square root of x. Let me that one homework. You know, for example, if you have a sine, you say what? You say it's equal to 1 over sine derivative of sine. That's easy. Understood what I say? Good. Question about the derivative? Yes. X squared derivative 2x. 2x. Y equal to x squared. So the derivative will be 2x. The 2 is coming down, and the exponent will be reduced by 1. Yes. Ln of course. Ln. So if you have a ln, we say y equal to ln of x squared. So I say y prime is equal to 1 over x squared 2x. Derivative of here is 2x. So later you can reduce x by x. So you will get what? 2 over x. You know what I mean? Okay. Any question? Yalla. Cheers. No question? Are you satisfied with that one? Good. Now I'm going to talk about something else. We say that after image, derivative, integral properties. These are important here. So you have this property. Just look at it and tell me if there is something you cannot deal with it. Just look at it, capture it, because later I'll give you example on each one of them. Do you have any question about the rule? We have LBX, LB over X, L1 over X, LXR. Now I'm going to give you example on that one. At the beginning, or for the first one, he say that if you have ln of, for example, x plus y, xy multiplication between them, you can say is equal to ln of x plus ln of y with anything. For example, I have ln of sine of x multiplied by 2x squared. So I see is equal to ln of the first one plus ln of the second one. So 2x squared. Any question? Do you have any question, dear? How about the multiplication or division? Ln of a over b or x over y, that be x by y. So I get ln of x minus ln of y. Example, ln of sine of x over x squared. So I can write down like that, ln of sine of x minus ln of x squared. Do you have any question about the second one? Please look at it, because I know I am faster because there's nothing to do with it. because later we are going this one, use all this one together. But careful, I have a question for you after these four properties. You have ln of 1 over x. You say that is equal to minus ln over x. Can you imagine why? Can you tell me why? Compare that one, the third one, with the second one. We say is equal to ln of 1 over x is equal to ln of the numerator minus denominator, ln of x. And I know this is very important. Ln of 1 is equal to what? 0. Do you remember the balance point? Say 0, 1, right? Sorry, 1 and 0. So that's why ln of, if you, I recommend you to write that one in some place. Ln of 1 equal to 0. Ln of e equal to 1. This is very important for you. Write down like somewhere else, I don't know. Ln of 1 equal to 0, ln of e is equal to 1. Do not forget about that one. That's why that one will be 0. That one will be ln of x. How about the fourth and the last rule here? We have what? Ln of ABC. Is like that? ABC? No, no. We have AB here. What do you mean by x, or let me say xy? X with the exponents. Y is exponent. So I say this one will come down here and I'll get ln of x. Any question? Example. For example, we have ln of x to power 3. I see is equal to 3 ln of x. Example, ln of sine to power 5 of x. I can write down as 5 ln of sine of x. Careful, ln is a function. It will be taboo to bring x out there. Ln is a function, like an integral, like a derivative. You cannot bring x out, okay? You cannot do that. It's forbidden. Understood what I say? Good. Now we have 4 properties here. These that's what we have. Here's my question. What we haven't. We have this property. What we haven't. No. No. Let me write down for you. No, okay. Tell me about that one. Ln of x plus y is equal to what? Equal to ln of x, like that? Okay. 1 over x plus y. You mean x plus y, like that? Like that? Plus between them? Okay, good. Other idea? Ln of x multiply ln of y. Any else? Okay, well done, thank you. None of them is true. We have no such rule that like that. Capture y. I'm going to the lecture to be more easier for you. My question was like that. Ln of x plus y equal to what? That was my question. Look at here. We have multiplication between two things. Okay? We'll separate to 2 ln, then addition. When I have 1 ln, 2 categories, 2 functions, 2 quantities, 2 things, I don't know. But here I have what? 1 ln with 1 thing, addition. So that's why I say multiplication is very important. Also for negative, we have nothing else. We have just itself. So means that if I want to speak that one or highlight that one, ln cannot distribute ln ln cannot distribute over addition and subtraction, but ln can be distributed over, look at here, multiplication and division. Did you get the idea? If I have ln with two things multiplied, I don't say 2 ln multiplied, okay? We have no 2 ln multiplication, no. We have no 2 ln multiplication or division, no. Just we have what? We have 2 ln, okay, addition, okay, so ciao. I can say is equal. These two will be 1, 1, and this addition will be multiplication. Understood, I say? If I have ln with something minus ln something, I say we have 1 ln, that one over that one. That's it. But I didn't have anything like that. Understood? So that's another point on the ln. That's all about ln. Now we are going to, I think, to talk about integrals. This example, just for your information, look at here. I have ln, okay. Again, I have ln, okay. We have addition, so I have 4 multiply sine. I have ln with a fraction, so I can see is equal to ln numerator minus ln of denominator. Ln is ln. So that's the rule. If I have 1, we say that, So this one not, or just for information. And proof, you know, is not include. So I'm going to also, again, this one proof is not include, as you know. So I am here. Here I am. We talk about that one. Limit is how we limit, take a limit for ln, and that's it. Any question? Before I'm going to integral, do you have any question? Hello? Do you have a question? No, good. Okay. Thank you. So we have integral, and look at here. Look at this rule. You will see this one in Cal 1, Cal 2, advanced calculus, differential equation. Anywhere you are going, you will see some integral like that. So that's very important as we say that. So integral in general is like that, dears. Careful. When we have, look and listen. When we have fraction means that I have something here, something there, dx, for example, dt, d theta, I don't know. The important thing is we have a fraction. The first. The second, derivative of denominator exists in numerator. What do you mean by that? For example, well, let me give you an example. I have x dx. Now I have a fraction, am I right? Derivative of denominator. Denominator is equal to what? 2x. Am I right? Here's denominator. So derivative of here, if y, for example, you say u equal to x, so du is equal to what? dx. Am I right? So derivative exists here. That's why I'm going to write ln of x plus c. Ln of absolute value of the denominator plus c. The general rule is like that. You see, if you have 1 over u du, in that case, I am going to write ln of u plus c. I will give you an example, just be patient. Here's the example to get the ideas. Simple example. Are you with me? Hello? Simple example. And the first. Here. Okay. So, how we find it? Look at it. We have x to power 3 plus 5x plus 2, 3x curve 5x dx. First, I have what? Fraction. Do not forget about that, please, because later, or in Cal 2, you have many types of the fraction. So careful. Now we have the first type of the fraction. when you saw fraction, you have two ideas. The first of all, think about len. Ask yourself, derivative of here exists or not? Just ask yourself, derivative of here exists or not? Exists. So directly you can answer. You can write len of denominator plus c, x cubed 5x plus 2. Easy, right? But do not mix between the others. But later I'll give you these two types that you got. Now we have the second type. This example, we say tan of x dx. Tan is equal to what? You get the idea with that one, with that example? No, just put it. Paste the denominator, paste the jera. That's all. You don't need to. Plus c. When you have an example. Oh, thank you. Now, before that example, I have another example. That one is simple. Sada. That one will be biryani. I'll give you biryani. Later, I'll give you a repeat during the exam. Okay. So, how we solve that one? Look, if I have such an example like that, dx. Actually, I will give you everything. That's why I'm going to ask about everything. Look, we have x here, x squared plus 5. Yalla, look. Wow, it's a fraction. Okay, fraction. So I'm going to ask about the derivative of denominator. Ask myself, yalla, derivative of denominator is equal to what? 2x. I have what? 2x dx. I have what? 1. So how we add 2? What shall we do? 2 to here. Thank you. Now I have 1 over 2 len of what? X squared plus 5. You don't need to think about it. You don't need to just think about it. Just write denominator. So balance the numerator with the denominator and go on. Understood? Do you need another example, dears? If I gave you 10, another 10 is the same. Now I'm going to another idea. Look at here. Tan of x. Before you are saying anything, I'm going to help you. Tan is equal to what? Tan of x integral. Second here. Second. If I ask myself, derivative of second is equal to tan or not? No. Derivative of second is equal to second tan. So means that the answer is not right. Thank you. Another attempt, another idea. So my question is what? Yes. Okay, so you are right. We don't have the direct. I told you we have a direct. Do you remember? We wrote everything and you took a picture. I remember, right? So we have a direct part. For example, sine, cosine, secant square is equal to tan. Do you remember that? Secant tan equal to secant. We wrote that one. But sine square we didn't have. We changed to something else. Cosine square we changed to something else. Why? Because we haven't direct way. The same thing is true for here. We don't have anything directly. So I'm going to change it. So how we change? We have a sign. There is no idea with the sign. Just we should do like that. Sine over cosine of x dx. Am I right? Do you have any other idea with the tan? No, we don't have. We stuck. Just we know about tan is equal to sine cosine. Okay, so tell me about the other one, other step. Later. Yalla, next. So think about you have what? You forget. You have what? Fraction. Am I right? So I'm going to ask myself what? Yalla Jamaat, we have a fraction. Here's the denominator. Derivative of cosine. I can hear you. Thank you. So minus sine. kidding, I can hear you, but just to make you busy. Okay. So we have minus sign. So what do we have? What I need? And now everything is ready. Am I right? So I'll say I have this minus, okay, ln of cosine x plus c. Any comment? Easy. And careful, in your lecture, no, this one is extra, I will give you. You can leave it here. Understood? That's the question as perfect. That's the, sorry, answer and perfect. Leave it. But in your book, they did something else. Just be careful. You say that this minus will come to here. Am I right? You know, ln will play with the exponent. We say that the fourth rule. So that one is like -1. So that one will be cosine of -1 of x plus c. Any question? And you know, cosine with the minus means that 1 over cosine of x plus c. Am I right, Jamaat? Please, if you have a gap, tell me. This is the rule. And I know 1 over cosine is equal to seconds. Am I right again? Of course. So that's why in your book, instead of that answer, you will see you have that answer. Both are true. Both are the same. Understood? Just do something else. Now is your turn. Can you solve cotan for me? Yalla. Can you solve? The same idea. We cannot solve cotan directly. Why? Because I don't have anything to write there. It's not in my list. Yes? Yeah, I'm going to write down what? Cotan is equal to cosine sine. Am I right? Derivative of sine, cosine. So I directed ln of sine of x plus c. Easy. Because you saw the tan, so cotan is easy for you. Any question? Yes. لا ما بس شلون minus 7 هنا يعني شيء. We have this rule. Ln of x a will be a ln of x. Am I right? Rule. So I have ln of sine. You got it? Good. Instead of a, we have -1. Thank you. Yes. Which one? That one? Okay. Tan is equal to sine over cosine, right? Wait. We have an integral of tan of x dx. We stuck. We couldn't do anything. We couldn't have any steps. Why? Because it's not direct. So we should do something. Multiply something. Separate them. I don't know. I'm going to separate them. I say tan is equal to sine cosine dx, right? Because I have a fraction, my idea will be on the ln. I'm going to the denominator. So I went to the denominator and I checked that the derivative of cosine is equal to what? Minus sine. So I need to add -2 here. Am I right? Because derivative of cosine is equal to minus sine. That's why. So you add minus, you should multiply another minus outside to balance your example, right? You cannot multiply by 2 without 1 over 2. You cannot multiply by minus without minus. That's why. So now we have a ln and we have a minus. Question? Okay. So here we are. Look at here. Later we'll go to solve that example. That one. So look at here generally without solving the boundaries. During the exam, if you don't know how to solve the integral with the boundary like pi over 2, sorry, minus pi over 2. So how we solve it? Forget about it. Just leave it. Just try to solve that one. So I'm going to ask myself, this is your example. You have a fraction. You have a fraction. So how we solve that one? Look, fraction بوها يكسب إلى شيء كمان ln. So derivative of say 0, derivative of 2 sine of theta is equal to 2 cosine. So I need 2 to outside. This one is extra. There's not 1 over. Because I have a 4. So that's why I'll get ln of denominator. You can say we'll get ln of denominator. Later we are going to substitute. Any question? Okay, so I will stop here because this is new idea and there's a unique idea. There's no another idea to solve for you. So I'm going to finish all things here. Thank you for listening.